Example: a market research group conducted a survey of 1000 consumers and reported that 720 consumers like product A and 450 consumers like product B. What is the least number that must have liked both products? Solution: let P and Q be the set of consumers who liked products A and B respectively. Then number of elements of P is equal to 720. Number of elements of Q is equal to 450 and number of elements of U is equal to 1000. Then number of elements of P is equal to 720. Number of elements of Q is equal to 450 and number of elements of U is equal to 1000. Therefore, number of elements of P union Q is equal to number of elements of P plus number of elements of Q minus number of elements of P intersection Q. Number of elements of P union Q is maximum when number of elements of P intersection Q is minimum. So, to have a least number of consumers who liked both the products, number of elements of P union Q must be maximum. Since P union Q is a subset of universal set, therefore number of elements of P union Q is less than or equal to number of elements of U. Therefore, maximum value of number of elements of P union Q is equal to 1000. Therefore, number of elements of P intersection Q is equal to number of elements of P plus number of elements of Q minus number of elements of P union Q is equal to 720 plus 450 minus 1000 is equal to 1170 minus 1000 is equal to 170. Therefore, least number of consumers who liked both products A and B is 170. Next example. A survey shows that 63% of the people watch a news channel, whereas 76% watch another channel. If X% of the people watch both, find X. Solution. Let A and B denote the set of people who watch a news channel and another channel respectively. Then number of elements of A is equal to 63. Number of elements of B is equal to 76. Number of elements of A intersection B is equal to X, and number of elements of U is equal to 100. Therefore, number of elements of A union B is equal to number of elements of A plus number of elements of B minus number of elements of A intersection B is equal to 63 plus 76 minus X is equal to 139 minus X. Since A union B is a subset of U, therefore number of elements of A union B is less than or equal to number of elements of U. that is 139 minus x is less than or equal to 100. This implies 139 minus 100 is less than or equal to x. This implies 39 is less than or equal to x. Say number 1. But number of elements of A intersection B is less than or equal to number of elements of B, because A intersection B is a subset of B. Therefore, x is less than or equal to 76. Say number 2. From 1 and 2, 39 is less than or equal to x is less than or equal to 76. Next example. Let A, B, C be three sets. Show that union of B intersection C is equal to union B intersection union C. Solution. Let x belongs to union of B intersection C. This implies x belongs to A or x belongs to B intersection C. This implies x belongs to A or x belongs to B and x belongs to C. Implies x belongs to A or x belongs to B and x belongs to A or x belongs to C. This implies x belongs to A union B and x belongs to A union C. Implies x belongs to A union B, because of and we can write intersection A union C. Since X belongs to A union of B intersection C implies X belongs to A union B intersection A union C, therefore A union of B intersection C is a subset of A union B intersection A union C. Say number 1. Next, let us consider let X belongs to A union B intersection A union C implies X belongs to A union B and X belongs to A union C implies X belongs to A or X belongs to B and X belongs to A or X belongs to C implies X belongs to A or X belongs to B and X belongs to C. This implies X belongs to A or X belongs to B intersection C. This implies X belongs to A union of B intersection C. Therefore, A union B intersection A union C is a subset of A union of B intersection C. Say number 2. From 1 and 2, A union B intersection C is equal to A union B intersection A union C. Next example. For any two sets A and B, show that A is equal to A intersection B union A minus B. Solution. RHS is equal to A intersection B union of A minus B. This is equal to A intersection B union of A intersection complement of B is equal to A intersection B union complement of B by using a distributive property is equal to A intersection B union of complement of B is nothing but as a universal set is equal to A intersection U is equal to A is equal to LHS.